Okay, and I'm going to make a start on this live broadcast for people revising for the second WJC paper. I've chosen a paper that is quite an old paper now, 2006, as you'll see. The reason why I've chosen that is just because it will hopefully give you some fresh questions that hopefully you haven't seen before. There are certain elements of this paper that aren't on the course anymore. Those bits I will just skip beforehand. Okay, so I'm going to work from the front to the back. Okay, so the first question tends in the new papers to actually make you go and find that midpoint column. Just trying to focus a bit better. So you'll probably have to go and find this value here, the 62.5. And the way that you do that, if you're unsure, is that you add together the first and the last term, press equals on your calculator first, then divide by 2, and you should get that value there. Now, what I've been telling my class to do is under the midpoint column to go and grey that out straight away, so you don't accidentally add it up, because people have got a horrible habit of actually adding those numbers up and you don't add them up. You need to create another column called midpoint times frequency, and that is when you're going to multiply those numbers. But being quite silly, I've got absolutely every piece of stationery known to man apart from a calculator. I'll just grab mine now. So using your calculator, you're going to work out these ones. The first one I could have done without a calculator, but just to be certain in the exam, what's the point in having a calculator if you're not going to use it? Obviously, the 62.5 I could write as 625, but my recommendation to you would be, if you're unsure, just use it. Even if you think, yeah, I definitely know this answer, just use it, just double check. Okay, 67.5 times 12, it's be 810. And 22 times 75.2, 1595, and so on. And so on, almost done now. Okay, so once you have actually found that column, you need to add up all of these here. To work out the mean is all of your numbers added together, divide by how many there were. And this number of people is how many people there were altogether. And it usually tells me somewhere in the question what it was as well. It says here 80 people. So that should add up to 80. This one here I'll have to add up on my calculator. And I get the answer 5895. Just a quick check to see if I'm happy with that. I've got two things that end in 0.5, so I was expecting that to get to a whole number. If it didn't get to a whole number, I knew I'd done something wrong. Again, so to work out the mean, or an estimate for the mean, because obviously we're saying that there were, like in this column here, there were 10 people between 60 and 65, so we're just taking a guess when we're saying it's 62.5. They could have all been 65, they could have all been 61. Okay, so that's why it's an estimate for the mean. So the estimate for the mean would be your total of your midpoint times frequency column divided by your total frequency. So in our case, that's going to be 5895 divided by 80, which is 73 point. Now I've got 4 dp answer. I'm going to write down the whole thing and then round it after. Now, it doesn't say anywhere that I actually have to round it to 1 decimal place. That answer would be fine. It would get you the full marks. But if you wanted to round it, you could to 73.7 to 1 dp, but just make sure you say what you're rounding it to. Okay? Okay, so question 2. Just going to try and get the focus a little bit better. There we go. Okay, so volunteers decide to give to 3 charities in the ratio 3 to 4 to 8. The volunteers raise a total of £6,000. How much will each charity receive? So ratio works by adding the numbers in the ratio together. So I need to do 3, add 4, add 8, and that gives me 15. And then I divide the sum of money in the ratio, so a total of 6,000, and then I divide that by the number I got in the first line. So 6,000 divided by 15. So sticking that into my calculator, I'm going to get 400. And then this answer here is 400. I multiply it by each of the parts of the ratio. Okay, so I get 3 times 400, 4 times 400, and 8 times 400. So I'm going to get 1,200, 1,600, and 3,200. So a quick check I could do to see if that is looking correct is adding all those all up. And when I add those all up, I get 6,000. Now that's not a definite indication that I'm definitely 100% right, but it's certainly a good indication that if it wasn't 6,000, I'm definitely wrong. Okay, so it's a good idea to do that, just to do a quick check and see if your answer's starting to look correct. Question 3. Now there's a shorthand way and a longhand way. If you are in my class, then I suggest you use the shorthand way we've looked at doing. But if you're in a different class and you've got a link to this, and you're watching this now, then I'd recommend that you just use whatever way you're comfortable with. Don't change your method this close to the exam. Okay, it won't pay off in the long run. Okay, so again, I'm just going to try and make that a bit clearer. Okay, so depreciation, furniture depreciates by the value of 24% of its value at the start of the year. The initial value of this furniture was £5,000. Find the value of the furniture at the end of 3 years. Give your answer to the nearest £100. We need to round this answer to £300. The important things in here is not only the number 5,000 is, the value to the nearest 100 here, depreciate, simply important word here, okay? You want to treat any sum of money as 100%. If it depreciates, I'm subtracting 24%, which is going to give me 76%, okay? You need to write that as a decimal, which should be 0.76, and then we want to do our sum of money, so our 5,000 multiplied by 0.76, and that will tell me the price or the value of that furniture at the end of the first year. So then we times by it again and again for 3 years, so we just put it to the power of 3. Okay, so that 5,000 is my sum of money. That is my percentage after I've subtracted 24%, subtracted depreciation. If it was compound interest, I would have added it, and then 3 because it was 3 years. And that just goes into my calculator, and it does the work very, very quickly for me. So we get 2,194.88 pence, but to the nearest £100, that would be £2,200. Okay? And then 4 marks, that's quite nice 4 marks, that one. Question 6. Okay, so having a quick look at the question. Oh, it looks like I lost my camera quickly. There we go. Okay, so looking at the question, I've got a parallelogram there. Now, it says ABCD is a parallelogram, so this one here, where AD is 12.5 and DC is 8.4. All that information they've already put it up in the question for us anyway, so it's not actually that important, that information there. It says find the length of CF. So it wants me to find this length here. Now what I have noticed is that it's within a rectangle. So AECF is a rectangle, so that means that must be 90 degrees. Now, in terms of what it wants me to do to work this out, I could use Pythagoras because I've got the hypotenuse there opposite the right angle. And although it doesn't look like it at first glance, I do actually know that length there by doing 15.7 subtract 12.5. So 15.7 subtract 12.5 gives me 3.2 centimeters here. And because I know what the hypotenuse is, I'm not going to use a squared plus b squared equals c squared. I'm going to straight away drop to that formula to being c squared minus b squared equals a squared, because I'm given the hypotenuse. So next I want to do 8.4 squared. Subtract 3.2 squared is equal to a squared. That's now going to my calculator, and whatever that answer is, it will give me the answer to a squared. So 8.4 squared minus 3.2 squared is equal to 60.32. So then I'm going to bring around this squared as a square root, square root in that answer to get a, and then square root in that answer gives me 7 points. Now I'm going to round that to one decimal place, just as in the question there, to 1 dps. So I'm going to do 7.8 centimeters, and I've got to say 1 dp if I've rounded it to 1 dp. Okay. Next, it asks me to work out or calculate the area of the parallelogram. You should know that the area of a parallelogram is just base times by perpendicular height. Okay, base times perpendicular height. So perpendicular height is what we just found. It's the distance between the bottom and the top. So the base of the parallelogram isn't 15.7, it's 12.5. So 12.5 multiplied by, now if I put in 7.8, I could lose a mark for a rounding error. I've still got that answer in my calculator from before, so I'm going to leave that in as answer because that is what the height is, and multiply it by the base, which is 12.5. So I get the answer, that thing originally, and when I press SD, I get an answer of 97.0824, blah, blah, blah. And then I'm going to round that to, I'm going to do it to 97.1 centimeters squared to 1 dp. Now, it's very important I did actually put my units to my answer, because it says in the question, clearly state the units of your answer. There'll be a mark for that centimeter squared. If you haven't got that, you'll lose a mark. That's one of the easiest marks on the whole paper, so you should do that anyway. Okay. Over to page 7. A prism has a uniform cross-section of 405.7 centimeters squared along its length 17.5 centimeters and is made from material that has a density of 5.42 grams / centimeters cubed. Calculate the mass in kilograms of the prism. Okay, that's not the easiest question that I've ever seen like this. Sometimes they're really, really easy because they usually tell you what to do in the question. So if you look here, it's giving me the answer in grams per centimeters cubed. But what we're going to do, because we're given what that is, we need to find out what the volume of the thing is in centimeters cubed. So if I've got a prism, so it could look like anything. Okay, a prism is a cross-sectional shape that has a constant cross-section. So if I slice that shape, I'd always see this thing at the front. So its cross-section, that thing in there, is 405.7 centimeters squared, and its length is 17.5 centimeters. So its volume must be the area of the cross-section divided by grams. Sorry, the other way around. Grams divided by centimeters cubed. So I don't know how many grams it was. So I'm going to say X grams divided by, I do know how many centimeters cubed it was. It was the answer I've just found, 7,099.75 cm cubed. And that has given me the answer 5.42 grams divided by cm cubed. So basically, to go and work that out now, I need to do 5.42 multiplied by the answer I just achieved, and that gives me the answer 38,480 0.645. So that should be enough to get me the answers. Just checking the mark scheme. We've got a load of rounded ones as well, and you can turn that. Well, we need to turn it into kilograms eventually, don't we? So the reason why times by that was because that's currently a divide, so I need to bring it around here because I'm saying that divided by that is equal to that. So when that divided goes round, it becomes a times. So x grams would be equal to 38,480.645. So then to get it into kilograms, I just divide that by 1,000. So that would be 38.480645 kilograms. Now that is a little excessive to write such a long answer. So I'm going to write it as 38.5 kilograms. And that's what's getting me the marks there. Okay, the trial improvement. Quite pleased this one's come up because it is to 2 decimal places, and we've normally seen ones just 1 DP in class. So when it's 2 decimal places, the rule is you always go 1 more DP. So we're really going to 3 DP, but only once. Okay, you don't go to 3 DP repeatedly. It's only the one time just to check. So we want to set up a table, and let's do a skinny start and end column. And this is going to be my x equals, this is going to be x cubed minus 12x minus 25 equals 0. And this is going to be my comment, whether it's too big or too small. Now, the first numbers you should always try are the ones given in the equation. If you try these two here, you get a mark straight away. So I'm going to write down 4.2 and 4.3. So I get 4.2 cubed. Now I always put my letters, I change them for open brackets and then stick in what the value is here, because then my calculator will deal with the BIDMAS from it. So 4.2 in there as well. And you should only put this into your calculator once. It's a bit of a pain in the backside the first time to write it. It's a long thing to write out, but it should only be once, and you should use your replay button then to just change the values. So that's all I put in. My calculator gives me minus 1.312. So that's too low. It's not above 0, so it's too low. So then I'm going to do it for 4.3. Exactly the same thing. Some questions I've been asked recently this week were, do we have to write out every time? When you do repeated questions in class, yes, it's a pain in the backside to write out every time. In your exam, do write it out every time. Just jump through the hoops. It's worth 4 marks. That means you've got 4 minutes to do it. So take your time and just use those 4 minutes up. It's a time-consuming question. We know that. That's why you're given so many marks for it. So that answer is 2.907, which is too high or too big. Okay? That is where I get my mark for going too low, then too high. What we say in consecutive numbers, that this was 4.2, then 4.3, 2, then 3 is what we call consecutive numbers. So that gets me a method mark for doing the correct method. So next, I'm going to go now. I could go 2 ways here. I could go 4.25 because that's definitely in the middle, and that's what some people always want to do. But I'm actually going to work a little bit smarter than that. And I'm going to try and answer closer to 4.2 because this answer is closer to 0 than this answer. So I'm going to try 4.22. But I could have tried anything. I could try 4.23. Or I could, if I want to just go to a default method, try 4.25, sorry, and definitely be like a way of starting to get the marks. But you must then keep on going through motions, get an answer that goes too low and too high again, and go in consecutive numbers. You don't want to accidentally miss a number. Okay? 2 cubed minus 12, 4.22 minus 25. So if I go and stick that into my calculator, 4.22 is coming across, and changing that to 22 as well. Then I get the answer minus 0.48 blah, 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 which is still too low. So now I'm going to go to 4.23. I said I'm going consecutive numbers. I'm not skipping any numbers. So now it's just a case of changing that to the 3. That to the 3. Now that's really close now. only just underneath. It's still too low because it's negative. And then 4.24. I'm guessing that's going to go positive now. Oh, luckily, right, because I pressed AC on my calculator, it actually keeps all of your previous calculations, whereas if I pressed on, it would have just deleted the whole lot. So I was quite pleased I accidentally only pressed AC then. So deleting the 3, there's the 4 there, and SD that. So there we go. Now that is too high because it is positive. It's above 0 now. So that's too high. And that's how I get the mark, by going too low, too high. But not only getting an answer that goes too low, too high, but these numbers here are consecutive, that these are one after the other, okay? Now, if I looked at those and said, that answer is clearly closer to 0 than that answer, which it is clearly closer to 0. If I then go and say x equals 2.23 to 2 decimal places, that is wrong. That will not get me any more marks. You must go to 3DP to confirm that, okay? So I need to do 4.235 to go in the middle of these two here. So 4.235 cubed minus 12 lots of 4.235 minus 25 equals. Now, as soon as they see that in the exam, they give you your third mark. As long as I get the correct answer for it and state, then I get what we call an axiom mark. I'm going to that one step further, and I get my axiom mark once I've got that calculation. And I get the answer 0.13 blah blah blah, which is too high, only just, but it's still too high nonetheless. Okay, now I've done that, I can actually go and get that mark there. But really what's going on is I've tried the answer 4.23, and that answer was too low, so I tried a bigger one, which was 4.24, and that answer was too high, so I tried a lower one, but I already have. So if I chop that line bang in the middle, go 4.235, that answer is still too high, so it's telling me to go for a lower number again, i.e. it's going to be less than 4.235, like 4.234 or something, which to 2 decimal places would round to this one here. Okay? Page 8. So certain questions, like I said, I am actually going to skip. So question 8, I can see that that came up on paper 1, so I'm not going to bother doing that. Okay. And we've got here now. The key to this one is literally in the question. It says in a sale, the original price. Whenever you read the words original price, you're thinking of 100%. It's reduced by 38%. And the sale price is $899. Calculate the original price. So my original price being 100%, reduced means subtract by 38%, and that is equal because the sale price is £899. So 100 take away 38 is 62%. So it's 62% that is equal to 899. Find 1%. If I find 1%, I can find any percent I want. Okay, so if I divide by the number in front of the percentage sign, but whatever I do to one side, I must do to the other, anything divided by itself is 1%, or is 1, anything divided by itself. In our case, it's 1%. So 899 divided by 62 gives an answer of 14.5. So to find 100%, I just need to times both sides by 100. So that's 100% here would be equal to that times 100, which is £1,450. Skipping question 8 because it's already come up. Question 9, each of the following numbers are in standard, or write each of the following numbers in standard form. The incorrect thing to do here is to count the zeros. It does work, but only with these ones here, and you have to use the minus. This one doesn't work. Standard form has to be a number between 1 and lower than 10. So it can't be 10. It's like 9.999 is fine, but it has to be lower than 10. So it's going to be 8.37. So I put the decimal point in there by here. So then just count how many numbers are now after that decimal place where I put it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be times 10 to the power of 9. Okay, just going to check that the mark scheme. Yeah, I have counted correctly. And then this one here would be 5.9. The fact that it's a small number means that it's to a minus power, and you can count the zeros for these ones, but be careful. Some teachers will tell you not to do that because it's confusing between the two. I remember it that it only works for the 0.0s. Okay, so 1, 2, 3, 4. The real reason why that works is because that decimal point is now in between the 5 and the 9, and if you count how many jumps that is, that's 1, 2, 3, 4 up to there. Okay, and then the next one, that goes into your calculator. Now, if it is a true calculator paper, this may have been out before these calculators could actually do standard form, but they put it in standard form now, unless it's a reasonable number. This button here, times 10 to the x, is a quick way of doing standard form. But if you do it, you don't need to do a power. It's already putting that minus 5 as a power for me. So then divided by 8.3 times 10 to the minus 8 there. Press equals. There we go. So we've got that answer there, which is quite a reasonable answer. You don't need to put that into standard form. That's why your calculator's not done it. Now, it's worth 2 marks. If you write this one here, you will definitely get one of the marks. Okay? So we're going to get 2650602. That's the entire display. It would be 5.662650602 times 10 to the power of, now that decimal point has gone to there, so it's literally just 2 numbers in between it, so it would be times 10 to the power of 2. Okay, some people say I've gone a little bit overboard, write out the whole number. I could have got away with saying 5.7 times 10 to the power of 2 to 1 dp. Okay, page 9, we're definitely expecting to see these on Tuesday. So again, all this information here they've gone and put into my actual questions, so it's not hugely important. But what the question says, find the length of BE. So going from B to E. Okay, now they've given us the length of DE. They've given us that bit there. So I need to find the entire length. So to do that, I need to know what this bit here is. Now, just a quick scan of the marks, can you see that it's only worth 3 marks, this question? So it can't be hugely difficult. I'm only expecting to use SOHCAHTOA or Pythagoras here, okay? Now, my gut feeling is I can't use this triangle. So, well, in fact, actually not my gut feeling, reading a little bit more carefully into it, I've only got 1 piece of information. I need to have 2, either 2 sides or a side and an angle, okay? So I can't do anything with this left-hand side triangle, but this one here, I've got an angle here and I've got the base of that. So to find BE, I just need to use SOHCAHTOA. So I'm going to label up my triangle properly. Here's my right angle, so that would be my hypotenuse. And 51 here, so this one here, which would be the entire thing of BE. It's not going to be BD, it's going to include that because I'm just pretending that triangle doesn't exist. That would be my opposite, and then this would be my adjacent. So we underline the sides that we know, or the sides that we want to know, and we want to know B to E. All of that bit there. So writing out SOHCAHTOA, off the ones that I know, so that is O and A. Wherever you see an O and an A, cross them off. The one that I double cross out, that's the one I use. So tan theta is equal to opposite divided by adjacent. Okay, you can subtract into that if you want to. Tan theta is just tan of the angle, so the angle is 51. So tan 51 is equal to the opposite divided by 4.8. So you bring that round as a times by, so 4.8 times tan 51. You can just write 4.8 tan 51, that's fine as well, is equal to the opposite. So my opposite is equal to just to say what calculator, I've got a little r up there because I was using this for 6th form work. Yours might be in that format. If it is, you need to change it to something called degrees mode. So if I press mode, that doesn't work, it's setup I need. So if I do shift and mode, it says deg for degrees, so we're working in 51 degrees. Okay, radians is another form of measuring, but when you get to A level. So let's do 4.8 tan 51, and then the answer is 5 points. I'm going to say 5.9 to 1 decimal place. Why 1 dp? Because in the question everything's done to 1 dp. Okay. And then for the next bit, it says calculate the size of BCD. So B to C to D, C with the little hat on, so it's that angle we want. Now, I said before that I only know one piece of information about that, but now I do know two, because I know all of this side is 5.9, and although I haven't got rid of it in my calculator for the next bit yet, I'm going to keep it in as answer. I can work out the green line by doing that side, take away 1.2. So on my calculator, if I just do minus 1.2, then that green line on my drawing is going to be equal to 4.727, blah, blah, blah. Now, you can either write this down. I'm going to write down a bit of it. So it's 4.72, blah, blah, blah. But what I'm not going to do is I'm not going to round it, because I can get penalised for a rounding error. Now, luckily for me, the way I labelled my triangle before, this being theta, this angle here that I'm missing, that's still opposite that angle, so that op is still op here. This would still be my adjacent because it's next to it, and this is my hypotenuse. Now this time, I know what the opposite is, it's that side there, and I actually know what the hypotenuse is, so I'm going to underline the word hype, and again, I'm going to write out the word SOHCAHTOA. So because I've underlined hype and op, I want to cross out anything with O or H in it. So O, H, H, and an O. Double cross out is sine. So it's sine theta is equal to the opposite, so that 4.72, blah, blah, blah. So I'm going to use that as answer my calculator, divided by 5.3. Now, if you know both sides, you want to take sine over, and sine, when it goes over, becomes sine minus 1 bracket, and it will automatically put that bracket in your calculator for you. And then you put in that side there, 4.72 blah 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 divided by 5.3, and then that will tell me what the angle is. So I'm putting it in as follows: shift and sine to get sine to the minus 1. Now I press the fraction key, ants over 5.3, and then you must bring round a bracket, not there on the bottom, we want it up here on the top. Okay, so pressing the equals there gives me the angle of 63.1234. So rounding that to 1 decimal place would be 63.1. But I must say that I round it to 1 dp. Quickly. And just check something here. Okay then. So we've got two very, very straightforward graphs here. So in fact, actually 4 marks of that is pretty generous. That's usually 3. The x is less than or equal to 3 is very easy. The y is greater than or equal to minus 1 is very, very easy. So that one there and there, easy. That one there, not too bad. I just need to draw an x-y table. But ones that we've seen in more recent times, they're giving a much worse equation that you have to get y on its own. You have to rearrange to get y on its own. So let me do x is less than 3 and y is equal to minus 1 first, because like I said, they are pretty easy. So you treat that as just an equals to begin with. So I'm looking for x equals 3. So I look on the x-axis until I find the value of 3 on the x-axis. And I draw a line straight through the value of 3. Okay? And I'm going to label that line as x equals 3 straight away, just up to the top. Now I'm going to do y is greater than minus 1, but I'm going to worry about the inequality after. So I'm looking for the y-axis, and I'm looking for minus 1, which is by here, in between 0 and 2. So I would draw that line there. Okay, and I'll get that bit straight for you. So this is y equals minus 1. And then I need to draw an x, y table to do this question here. So we do x up at the top, and y is equal to 3x minus 2. And you can chuck in any numbers you want here, but you've got to be able to plot them. I always go for the counting numbers, 1, 2, and 3. But if I can't plot one of them, I'll have to do a different number. So y is equal to 3 times what x is, then take away 2. So 3 times 1, in this case, because x is 1, 3 times 1 is 3, take away 2 is 1. Then here is going to be 3 times 2, then take away 2. So 3 times 2 is 6, take away 2 is 4. And finally, it's going to be 3 times 3, which is 9, take away 2, which would be 7. And can you see how those numbers go up in threes? That's no coincidence because the coefficient of x, the number in front of x, was 3. That meant it was going to go up in threes. Okay? So from here, I need to plot those points. So 1 and 1. So cross 1 up to 1. 2 and 4. So here. And then 3 and 7. Now I'll know if I've worked those out correctly because my ruler should go through all 3 points. If it doesn't, I've done it incorrectly. But can you see there my ruler does? So I'm going to now draw that line there. Okay, so that green line is y is equal to 3x minus 2. And do you notice how it goes through minus 2 on my y-axis? That second part of it, the 3x, then the minus 2. The minus 2 is what we call the y-intercept, so it should have gone through minus 2. Okay, now if I had to bet any money on it, I'd say this is my region here, but I'm going to prove it to you now how we know it is. So we've got 3x, x is equal to 3. But in the question, it said it wanted the region where x was less than 3. So it wants the ones where it's less than 3. So that means I don't want this stuff here. Okay? So I shade out the stuff I don't want because it will leave my region nice and clear. Then it wanted y was greater than 1. So it wanted everything above this y line. So that means I don't want all of this stuff here. Stuff under that line. Okay, and then finally for this one here, for the green line, it wanted y is less than or equal to 3x minus 2. So we pick a point somewhere either side of the line, and this is my favorite point because it's very easy. This is the origin, so x is equal to 0 and y is equal to 0. So what we do is we just chuck in 0 and 0 into that and see what we get. So we get y, sorry, not y, because we just say 0. 0 is less than or equal to 3 times 0 minus 2. So 0 is less than or equal to minus 2. Is 0 less than 2? No, that's not true. That's false. So this point here is not the side of the line I want. So I can shade out everything this side of the line. Okay, so confirmed exactly what I thought going into the question. Now, in terms of make sure that you indicate the region that your answer represents, I've left a lovely blank region, but I don't know if I've clearly indicated that's my region. I'm going to call it R, and I think that's really obvious now that that's my region. Okay? But if you have done that, we'll obviously skip on to it. Really like these indices questions when I saw them. I thought they're quite hard. I thought they're good ones to look at. ABC to the power of 0, anything, no matter what it is, anything to the power of 0 is always equal to 1. Okay, so easiest mark on the paper if you just remember that definition. This one's really tricky. You need to know that to the square root of anything is the same as to the power of a half. And then this would still be to the power of 16 here. And when you've got brackets like that, what you need to do is just multiply the numbers. So you're going to get y to the power of 8. Okay? This one here, numbers deal with numbers. So 28 divided by 7 is 4. I'm going to deal with these indices up here first. I'm not going to try and do anything with the a there. I'm going to take it in 2 parts. So 9 over 2 times minus 5 over 2. That's just doing, we add the indices. So I want to do 9 over 2. Add, and then it is a minus 5 over 2. Stick it into your calculator if you want. It's a calculator paper. Okay, it's just 2. So that is a squared over a. I've got rid of the 7 because I did 28 divided by 7. Okay. Now this a is to the power of 1, and when they're dividing, you subtract the indices, so we get 4a to the power of 1, or just 4a. Okay. And then for part D here, can you see how this bracket is the same on both? So I can basically cancel out. I can take away the 2 from there. So I'm going to get 5x to the minus 2, and then 7x plus y to the power of 3. But I'm still over 6x there. So I can subtract the x powers here. So that's going to remain as 5x to the minus 8, and then 7x plus y to the power of 3. If I wanted to, I could have then written that on the bottom there. Okay, but I just leave it as that. It's more faffing around than anything else to then take that down. Okay. This, I've got a feeling this is going to be on the exam. My gut feeling is this is due an appearance. So have a quick read of the question. It says the diagram shows a circle 0. Now, as soon as it says about a circle and it's asking about lengths of circles, then you need to remember that the formulas are area equals pi r squared and circumference is equal to pi d or 2 pi r, whichever one works for you. Okay, I probably prefer pi d as personal preference. I'd write that down as soon as I get into the exam. So like when they say you can start writing on your exam, I turn to the formula sheet and write those down. There's a couple of things I write down. Histograms, I write down FD equals F over CW, which is the formula for histograms, etc. Okay, so there's a couple of things I recommend writing down. To find the length of an arc, it wants me to find out what this distance here is. So the curvy bit is what we call the circumference, okay? But I don't want the entire circumference, I don't want the whole thing. I want 46 degrees. It's 46 degrees out of 360 degrees, out of the entire circle, okay? Then I want to times it by pi d. Okay, so what am I told in the question? It says the circle has a radius of 8.2. Radius of 8.2 means the diameter is double of that, 16.4 centimeters. So I want to do 46 over 360 multiplied by pi times by 16.4, and that literally just goes into my calculator, and it's 3 pretty straightforward marks. You know, it's coming up to question 14, so they're giving that an A grade rating now. I don't think it's that hard, and I think for anyone going for their C grade, that's something you should really be targeting and trying to get those marks. Okay, so that gives me the answer of, now it gives it to me in my calculator still in pi. So all you do is press SD to take that out to being pi, and I get the answer 6.5. I've already written 5 now, so 5.8 to 2 dp, but I could have said 6.6 to 1 dp, and then centimeters. Okay, so there's my answers there. Question 16, sorry, which I can just see just ahead. That's not in our spec, so I'm going to just stick a line through that in a second. I think it's stratified sampling. Yeah, that's gone. This one is very much in our scheme of work, and you know, I'd be shocked if this isn't in there. So we're getting towards the end of the paper. We're seeing a triangle. As soon as you see a triangle towards the end of the paper, especially as I can see, it's not got a right angle. They've not put a square anywhere. It's either going to be sine or cosine here, or the area thing. But I need to read the question to find out what it's asking me. Okay, so it says, here's my triangle, given that PQ is that, so all that information again, which you've already put in the drawing for us, calculate the length of PR. Okay, so I need to find this length here. Do I know the angle opposite it? Yes, happy days. Opposite it, yep. So I can go ahead and solve this. If they could have said find QR, so I'd need to find the angle opposite in that case. So I've got one side and 2 angles, and I want to know another side. So by the end of the question, 2 sides and 2 angles. That is telling me to use the sine rule. Okay, so it's a case of scanning back to the formula sheet if you're unsure. Now it's got sides over the angles there, so A over sine A, B over sine B, C over sine C. That's great for when I'm finding a side. If I was looking for an angle, what I'd do is I'd transpose all those, so I'd flip all the things. So it said sine A over A equals sine B over B equals sine C over C. Okay, but you only ever use 2 of them. You don't use all 3. So in our case, I want to find the side. I want to find the side PR, which is what we call little q. Opposite the angle, you call that the little letter. So this would be little p, and this would be little r. And I want to know that one and that one. I don't want to know that one, and I don't know its angle. Okay, so because I want to know a side, I'm going to have it as r over sine r is equal to q over sine q. And it'll be a case of substituting that and now just rearranging it to solve. So r, 12.6 over sine 31 is equal to little q over sine 76. So what I do now is I take over the sine 76, and it becomes a times by sine 76. Okay, so 12.6 over sine 31, and that will tell me what Q is. Oh, sorry. I could put it in up on the top of the numerator. I'm not going to bother. I'm going to leave it as that. So sine 76. Close the bracket. If you don't, it will say math error or something. 12.6 over sine 31, and close the bracket, and I get Q is equal to 23.7 centimeters, and again to 1 decimal place. Make sure you say what you're rounding to. Okay. So we've already said question 16 is off the spec. We don't do that one anymore. Okay, question 17. So again, quite easy marks. Now the key word that I'm looking for here is similar. As soon as you see that word, you need to write down small times scale factor is equal to big. Now that only works for straight lines. Okay, I'm just going to try and focus it a bit better. There we go. For area, it is small times scale factor squared is equal to big. And then for volume, it's small times scale factor cubed is equal to the big one. Okay, and again, something to write down as soon as you see the word similar, I knew to write that down straight away. So it tells me here, it says the lengths of the lengths of an edge of the larger tetrahedron are 4 times the lengths of the smaller one. Okay, so that's telling me what my scale factor is. My scale factor is equal to 4 of the corresponding edge. The volume of the smaller tetrahedron is 3.8 centimeters cubed. So 3.8 centimeters cubed. Then my scale factor is equal to 4. Calculate the volume of the large one. So as long as I know this thing up here, piece of cake marks. So we've got 3.8, which is the volume of the smaller one, times by the scale factor, which is 4, cubed. And that will give me what that answer is. Okay, 3.8 times 4 cubed equals, SD it's 243.2. And that would be centimeters cubed. Okay, easy marks if you've learned that bit there. And then 18, right, these ones are really good for my class because we've been looking at ones like this throughout the last couple of weeks. Have a quick read of the question. Okay then, so it says this triangle is right angled at Q. The length of PR is equal to that. The length of PQ is equal to that. Now this information they haven't put into the triangle, so it might be worth actually going and sticking this in. So PR is 23.6 centimeters. And it says the length of PQ is X. And the length of QR is 6.2 centimeters longer than PQ. So PQ is X, and this is 6.2 centimeters longer than it. So this would be X add 6.2. Okay, so I'm going to put that in a bracket because there's 2 bits to it. Show that the equation, show that X satisfies the equation X squared equals that. Well, I've got a right angle triangle, and I know all 3 sides. So I'm going to use Pythagoras. So it's going to be X squared plus X plus 6.2 squared equals 23.6 squared. Okay, that's how I'm going to do the first bit. I obviously don't know what that is squared. Okay, so I'm going to take my time with that. That's where you're most likely to make a mistake here. So X squared, that just stays as X squared. I'm going to write that as X plus 6.2. Squared means times by itself, so I'm just going to write that out. And then 23.6 squared I'm going to work out in the calculator. So I've got it as 556.96. So we're going to have by here, that's going to remain the same. Okay, so here I'm going to get X times X, which is going to be X squared, so plus X squared. And then here, I'm going to have x times 6.2, which would be 6.2x. So I'm going to say plus 6.2x. I'm also going to get another one of those, plus another 6.2x from this one here. And then 6.2 times 6.2, no idea, so 6.2 squared is 38, so plus 38.44. Okay, now it's going to be a case of arranging that, collecting all the like terms. So I'm going to get x squared plus x squared, which is 2x squared. 6.2 plus 6.2x would be 12.4x. And then I'm going to bring this over because they've got it in the form equals 0. So I need to bring that over. So I'm going to have plus 38.44, but I'm going to take away 556.96, which is minus 518.52. And that is equal to nothing now. Now, you should be looking at that thinking, oh, no, I haven't got what they've got in the question. They've got x squared, they've got 6.2x, they've got a different number there. That's not an issue. Look, we've got 2x, 12.4. That's just twice as much as that. So what I need to do now is divide the entire thing by 2. So if I divide that by 2, I get x squared plus 6.2x, just like they've got. And this bit here, I'm pretty sure if I halve that, I'm going to get that number. At least that's what I'm hoping. When I do halve it, I do get exactly that number. Okay, so that would then be 259.26 equals 0 as required. Okay. The next bit here, there's a massive hint to what you need to do. It says solve the equation, calculate the lengths P, Q, and QR, giving your answers correct to 1 decimal place. Now, as soon as I said to 1 decimal place, that is telling me to use a quadratic formula. Okay, so I'm going to write down A equals, B equals, and C equals. So that is going to be 1, 6.2, and minus 259.26. Okay, so from here, look at your formula sheet again. Quadratic equation is given to you. Just go and read that out, write it down. I'm going to start subbing straight into it. It's going to be minus B, so minus 6.2. Plus or minus, that means once in my calculator I add it and once I subtract it, and we get 2 different answers because it's a quadratic. So I get the square root of 6.2 squared minus, now stick this bit in a bracket, 4 times A, so 4 times 1, times minus, very important you include the minus there, 259.26. But in the real exam, don't write in this bit here because it says for examiners only, okay, so don't do that. Okay, I just need to make more space. I'll write it underneath if needs be. So then underline that bit there, and then that's over 2a. So that's just 2 times 1. So in our case, it's just 2. Didn't really need to write in the 1, but just to show you that it is there. So stick it into my calculator. Press the fraction button to begin with. 6.2. So the first time I'm going to add the square root. So I get 6.2 squared, and then I'm going to take away 4 times 1, so just 4, and then 2.5, or minus, if I'd missed that, it would have messed up the entire thing. 259.26, close your bracket, all over 2 times 1, which is just 2. So when I add it, I get the following answer. So I'm going to say add x equals 13.297 blah, blah, blah. And when I subtract it, what do I get? Now, short hint for you here. If you press left, you've got to go through the entire thing again, and it takes ages and ages and ages. If I'd started pressing right here, I can just go and right at the start and change that plus to a minus. Okay? So I get minus 19.497, blah, blah, blah. Okay? From there, it's pretty obvious that one of those answers can't exist. This is telling me that my length PQ is a minus number. That can't be right. That doesn't actually make sense in real life. Okay, so that one I'm going to discard. So to work out the length of PR, well, PR was X, wasn't it? So it'd just be 13.3 to 1 decimal place, centimeters. And for QR, that was X, but it was plus 6.2 because it was longer, wasn't it? So it's going to be 13.3 plus 6.2. Okay, so my answer for that is 19.5. So that was adding the two together, 13.3, add 6.2. Okay. Over the page, thirds definitely came up, so I'm not going to go through it. I'm not sure these ones did, but again, my class is pretty good on that. Don't want to do that. You've got your own way of solving, which is brilliant. This one here, 20, that's now off the spec in terms of standard deviation. I would say it's worth doing to do the estimate the mean, but we've actually done that already, so I'm surprised they put it twice in one paper. You just do your midpoint column. As soon as you do your midpoint column, cross out underneath it, and then that would be 75, that would be 125, that would be 175, and that would be 150, that one, wouldn't it? Not 150, sorry, 250. Just check your things. It's not that they always go up in the same numbers every time. Worst case scenario, add that one to that one, press equals, then divide by 2, and it will give you that answer. Then do your midpoint times frequency. But I'm not going to bother doing that because we've already done all of that today. Okay, so add together your frequencies. It probably tells you in the question how many are there, 50. Here would be whatever that is. So then you do whatever this answer here is divided by the 50, and it would be your estimate the mean. Okay, and over the page. Now this is a good one to do. So it says we've got a cyclist travelling a 20-kilometre route starting at 12 noon from Abbeyfall, reaching Beaconfield at 2 p.m. The following diagram. Where was he fastest? That could be a question that you could see here quite easily. He would be fastest where the steepest part of the graph is. The following, what else could you get asked? Did he stop anywhere? He'd stop if the gradient was equal to 0. And that basically works out the speed by doing the gradient, okay? So here, he's only just moving in here. He's really slowing down here. That's pretty, he's going quite fast here because it's quite steep. Okay, it says use the graph to estimate the speed of the cyclist at 12:30 p.m. Now I didn't like the scale when I had a look at it earlier because 12:30 isn't like one of the bold lines, but it doesn't matter. I know it's 3 squares here, so it's going to be 1.5 squares in here. So what you do at 12:30, you go and find the point on the graph and draw a point there. Okay, you're going to draw a tangent to that point. Now when you draw your tangent, I'm going to draw a couple in pencil to show you really bad tangents. This would be a really bad tangent. Okay, the reason why that's a bad tangent is this area here is not the same as this area here between the tangent and the curve. It should be that when you draw a decent tangent that you have it the same area underneath. So think of it like a bow tie. So I'll draw one here. Bow tie, you want to have the same area each side, don't you? If you had like a really, really weird bow tie like that, you'd look like an idiot, wouldn't you? Okay, so you want to think of your tangent being like that. So for me, I need to make that a little bit more to that side, a little bit more this side. And I think I'll be happy with that one there. That for me looks like the same area roughly. So what I need to do now is work out the gradient of that line. So to work out the gradient of that line, you want to find where it goes through a square nicely and then another square nicely. So for me, that point there is not too bad. It's on 20. And if I go down to the 10 line here, then I can have quite a nice gap here of 10. So I know how much it's risen is 10. So I need to go and work out how far it's gone across in that time. And you've got to be as accurate as you possibly can. I can see that's the first one there, and then that one's one back. So let's work out what the scale this graph is. So if that is to 12:30, that is 15 little squares, isn't it? I've got 30 minutes in 15 squares. So that's telling me that each little square is worth 2 minutes. So I've gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I've gone 18 squares there. So times that by 2 would be equal to 36. So to work out the speed, I would do rise over run. So that would be a run of rise over run would be a rise of 10 kilometers in 36 minutes. Now that's a bit of a fuss, isn't it? You don't go and work out things certainly in terms of speed. If I asked you what the speed was on the motorway, you wouldn't tell me it's so many miles a minute. It's actually 1 mile a minute. No, it's not. If it was 60 miles an hour, it would be 1 mile a minute. So I need to change that 36 minutes into hours. So the way that I do that is doing 36 divided by 60 because 60 minutes goes into 1 hour. So 36 divided by 60 is 0.6 hours. So then 10 kilometers divided by 0.6 hours works out at being 10 divided by 0.6. Works out at being 16.6. 16.6 recurring kilometers per hour. And let me just have a quick look what's given in the mark scheme. They've given in the mark scheme. I'll show you what I can see. They have given 14 plus or minus 3, so I'm allowed up to 17. So my tangent actually, in hindsight, wasn't that good, all the way down to 11, somewhere between those two values. Yeah, I was around the top there. Ideally, being a maths teacher, I probably should have been closer to 14, but that pencil line is what messed me up. That's what I'm sticking with anyway. Okay, and what have we got over the other side? We've got question 22, which has already come up in paper 1. Okay, so that is going to conclude our paper, and I will leave it there. Good luck. Hope that was useful.